Okay, great. We can start. Many people joined, and it's 10 minutes past 6. So thank you everyone for coming. Today we will have TypeScript talks. We have put together 2 topics on TypeScript. One topic is first presentation will be kind of introductory, and the second one will be a bit more advanced about some utility types that come with TypeScript, and we will see some details of behind the scenes, how does TypeScript actually understand some of the types that we write. So without further ado, we can start with the first presentation. So I'll quickly share my screen. Can you hear us okay? Background noise, okay. Okay, so I think we can now slowly start. We'll just maybe close the window real quick. Maybe that's the background noise that we're getting. And I'm at the last slide, nice. Let's jump to first slide instead. Okay. So my name is Filip Voska, and I'll be presenting this first presentation that we have, Introduction to TypeScript. So first question is, what is TypeScript, of course? And if you're a smart person, you might say that it's a superset of JavaScript. And that's kind of, that's true, but also a really smart answer. Another smart thing that you could say is that any valid JavaScript is also valid TypeScript, but that could maybe be a lie, depending on what type of JavaScript did you write, because JavaScript is really like a lenient language, and you can write all sorts of things. So TypeScript, you can write basically JavaScript in TypeScript, but you will have some additional features. So here are those additional features that TypeScript adds on top of JavaScript. So here I listed just some of the most important ones, and that includes types, interfaces, namespaces, sugar for classes. We will see something about that. Abstract classes, generics, or templating is called different in different languages. Decorators, enums, tuples, etc. We have many more things here. So the most basic thing that TypeScript does, as is suggested by its name, is types. So let's look at a real simple example of some JavaScript code where we have a variable called value, and we assign it initially to value 42, a number, and then later on we reassign the same variable to string 42. Now this is perfectly valid JavaScript. JavaScript has a dynamic type system, and you can assign a different type of a value to the same variable throughout the whole application. Now, if you write this in JavaScript, remember that I mentioned that any valid JavaScript is also valid TypeScript, but here that's actually not the case, because depending on how strict TypeScript is, this will actually not be valid if you write it like identically like this is. So it will complain that the value string is not assignable to type number. And here we can see that TypeScript has kind of assumed that the type of variable value will be a number. And later on, we try to reassign a string to it, and it says, okay, you can't do that. You said on line 1, when you declare the variable and assign it initially, that it will basically be a number. Because behind the scenes, TypeScript sees something like this. So it can infer the type based on your initial value. And it inferred that the initial value is a number, and it will treat the variable as being a number variable throughout the whole scope. So that's why we see this error. So those are types. So we add this column symbol and we write a type. And if you are in like VS Code editor or many other editors as well, when you hover over a variable, you will see that there is an inferred type of number. That is something that the TypeScript compiler tells us that it's a number. And there are many different types of values or many different types of types. And real great wording. So you can have numbers, strings, all the basic primitives. You can have symbols. You can have objects, arrays, some custom classes you have, or you can write some custom types of your own. There are some kind of special types, including any, unknown, void, never, undefined, null. Those, I think some of those my colleague here will cover later on. But just quickly, any, if you set that the type is any, you can basically assign anything to this variable at any point. It doesn't matter, you can assign a number to it later on, you can assign a string to it, it will be fine. Unknown is when you kind of don't know the type ahead of time, or you are just not interested in the type at all. Undefined null, when you like do a real, when you like return undefined or return null, it will be that type. Void is when you don't return anything. For example, if your function just has an empty return statement, then the return type of that function will be void. And never, that's also a kind of strange and interesting type. Never, an example of never would be if your function always throws an error, for example. So it will never return any value, it will always throw an error. So that's when the return type of such a function might be never. So let's look at a couple of more examples. So here we have a function where we can add types to each of the parameters of the function. So we have parameter name and parameter age. Name is a string, age is a number. And the function returns user. So user is a class that we have defined somewhere in our application. And what this means is that our method create user will return an instance of a user class. And we can say that in line 2 that we create a new user with some name and age. You can have a union of types. So here we created a custom type, which we named it number or string. And we said that this custom type, it can be number or a string. And if we have two values, two variables which are of type number or string, we can assign either a number or a string to those variables. We will see a bit more about unions and intersections later on. Now, real quickly, TypeScript also adds enums and tuples. Enums, you would usually use them if API returns you some strings, which are kind of codes. For example, for countries, API might return you Croatia or Great Britain strings when, depending on which country the user is in. You could create in your front-end application an enum for this, and throughout your whole code base, you would use that enum. So if maybe the string Croatia or string Great Britain changes, you can change only the string here in enum. You don't have to go through the whole app and change basically hard-coded strings. Tuples. Now tuples have really similar syntax to arrays. So if you declare a type, custom type let1, and you say that that type is an array of two numbers, then you can on line 2, for example, you can create an array of 2 items and you assign it to some variable, and that variable you have defined here that it is of type let1. So if you add more items to the array, or if you add only 1 or 0 items to the array, you will get a compilation error. And similarly for like point 3D, that might also be a common use case where you simply have three X, Y, Z points and you want a type for that. And you don't want to wrap it in like an object, although I mean, array will be an object, but this is one of the simplest solutions for such cases. Next big thing that TypeScript adds is interfaces. Now, interfaces, they exist in many languages. And here, looking at this first example, we will be using the interface to define some kind of a data structure. So, for example, you might use an interface to define some JSON data structure that you get from the backend, or maybe that you are sending to the backend. And here we see that our interface IUser, we usually name interfaces prefixed with capital I, just kind of to discern them from, if maybe we also have a class user and we have an interface IUser, just to be sure what's what. So here for IUser, we have a name, which is type of string. We have, and then we have age, which has this question mark before the column, and that means that this age property will be optional, or in other words, you can leave it as undefined. Now for the address, we can also like address is also optional, and we can use some other interface as the type for the address. And then we have the interface address, which has address and city, which are both strings, and it has country, which is our enum from the previous example. And now you can create two objects. First object would be like really simple, only name, because age and address are optional, so we can create an object of type IUser with only the name. Or we can go like all in and add the age and the address and everything. And this is not my personal address. Please don't swat me. This is the office address. Okay, so we have shown an example where an interface is used to define data structure, but you can also define an interface for like object-oriented programming. So here in this example, we have created the iLoading state interface, and this interface has a property is loading, which is a Boolean. And now, for example, our component, which is a class, so this is like maybe old React or Angular example. So our component will have to implement iLoading state interface. And here we see that we have to add this line 6 is loading, and we set it to some initial value. If we do not have this line 6 here, we will get a compile error, and it will say that my component does not implement the interface. So we need to add this property. And then we could have like load data method in our component that once it's finished loading the data, just flips the value to false. Another kind of interesting thing is that interfaces can extend other interfaces. So that's maybe kind of unexpected, but it could be useful. So if all of your data models, if they all have a string ID, you could like create identity interface which contains this ID, and then all your other interfaces can extend this identity interface, and then IUser will also need to have ID as well as name and age. Now here's another new bit of syntax. Here we have defined an interface hash map. And what we want to achieve is we want to have, let's look at the example first. So we want to have an object that can have properties where keys are strings. And then as a value of that property, we can have basically anything. So it can be, well, not anything, we can have an object, but we can have basically any kind of object. So here we see that our interface I hash map, it has, we say here that properties will be keys of type string and values will be of type object. One thing that you cannot do with interfaces is you cannot instantiate interfaces. So if you try doing something like this, you will get an error because IUser only refers to a type, but it is being used as a value here. So what does it mean that it is being used as a value? Well, here, if we want to instantiate something, we need to have a class or like a constructor function, but interface is not that. In fact, if you look at, so here on the left side, we have TypeScript code, which is like just this interface and some variable that is of the typed as IUser. If we compile this code, you will notice that our JavaScript code has basically no mention of this interface. And that is because interfaces are only used during completion time and to organize your code a bit better, but they are not something that exists in the final application bundle. So they are basically only compile time thing. Now, I am already apologizing for this example. Some of you might already see where this is going, but I have created 3 interfaces here. IMan, it has property name of type string. It has a function or a method called speak, which does not return any value. It's of type void. And we have interface iBear, which has method roar, and ipig, which has method squirrel. Now, we have previously seen that we can create custom types. And here we have created a custom type called man or bear or pig, which is of type iman or ibear or ipig. And now we can create a man object, which is of type man or bear or pig. And we can take like just things from the man interface and define this sort of an object with the property and the function. And we can do the same thing for bear. We just add some roar method, and we can do the same for pig. We just add the squirrel method. So this is all valid. We can, so this is because we have this union of type of interfaces. We can also have an intersection of interfaces. And in this case, we can create my favorite type in this whole presentation, man, bear, pig. And if we create an object that is of type man, bear, pig, it can have basically all the things from all the interfaces. So we get an object that has everything. And please, if you are sensitive to Gore or to L-Gore, please look away because there is a graphic piece of content coming up. So you get man, bear, pig. And this is basically the highlight of my presentation. It's downhill from here. Okay, so next thing that TypeScript adds is some sugar for classes. So the first thing that is kind of really something that you would expect if you have classes in some object-oriented language, you would expect accessors like private, protected, and public. JavaScript does have classes, but it does not have like private, protected, and public accessors. So that is something that TypeScript does add on top of JavaScript. So here we have a class user that has a private property name, and it's of type string. And we simply have a constructor where the constructor will receive parameter name and assign name to the private variable. And so later on, if we create an instance of the user and we try reassigning the name property. So if we try this, we will get again a compilation error because property name is private and only accessible from class user. So if you look at the compiled JavaScript code based on this user TypeScript class, we will see that the property basically disappears and there is no mention of private. That is because private does not exist in JavaScript. So looking at this compiled JavaScript, you're thinking like, okay, but what is stopping us from just reassigning this name from this class? And you can indeed do that. You can do that by casting the user object to any, and then you can reassign the name property. Once you cast something to any, you can do basically anything with it. So this will no longer check if name is a private property. This will just compile and it will let you do it. You shouldn't do this. I mean, it will compile and it will work, but this is kind of defeating the purpose of having a type system. So we usually have like linting rules that show as a warning or as an error whenever we use type any. Because if you're using type any, I mean, you might as well not use TypeScript. If you really want to have like a private property, then there is a proposal for JavaScript. I'm not sure, I guess it's still in proposal. It's supported somewhere already, but I'm not sure. There is this new syntax for true private properties. And you can see this hash property name syntax. If we use this type of syntax, then this will truly be a private property in runtime as well. And you can see that this gets compiled to JavaScript with this hash property syntax. So ideally, this is like the final goal for private properties. This is what we will be using once the support is good enough for this. And now the one more sugary thing. So you can see here, so if you want to create a new instance of class user, you pass name and age in the constructor. You have private properties, name and age. And then in the constructor, you just assign those private properties. So once someone creates an instance of the user, they can no longer change either name nor the age. But this is kind of, you have repeated string name here 4 times. So here we say name, here we say name. So this is like really repetitive. And if you have many properties, this is like really ugly as well. And this is a bit of sugar. If you just place private, public, or protected in the constructor parameters, you will get identical kind of functionality. So it will assign, it will have a private property and it will assign the value at construction time. So you don't have to type all of this every time. One other thing that we get is read only. So here, previously we had an example where name and age were private, but now we have said that name and age are public, but they are read only. So you can, for example, console log the username, but you are still unable to reassign it because it is a read only, marked as read only. And here, depending on how strict you have set up TypeScript to be, so I think this is one of the compiler options. I think it's strict null checks. So here, if we have public read-only name of TypeScript on a class, this will actually give a compile warning or error actually that property name has no initializer and is not definitely assigned in the constructor. So this means that if we leave things like this, we have to either assign it here in line, or we have to assign it somewhere in the constructor. This is because if you do not do anything, value of the property name will be undefined. But we have declared here that it is a string. And if we have strict null checks, then we have to say explicitly that it could be undefined or maybe null. So you have a couple of options here to resolve this error. One of them is to mark the property as optional with question mark. This will basically mean that the value can be undefined. you can add an exclamation mark. And exclamation mark means that, so basically you're saying, okay, someone will assign this value. I'm not sure who will assign it, but rest assured that this will not be undefined. It will be set at some point. One example for this might be if you have in Angular, if you have input to the component, you might decide to add this exclamation mark if you are expecting that the parent component will always send some value for this input. Another simple option is to just default to something like an empty string or whatever makes sense. Or you could move this to the constructor, and then whoever is in charge of creating a new user, he will have to pass a name there. Okay, let me grab a sip of water. Okay, now we have generics and abstract classes, and this is like prime object-oriented programming features. So first, let's look at generics. So even out of the box, you have this array type where you can define of what is it an array of. So this is an array of a string, and we can create an array with 2 strings in it. Now this is the type, and this is called a generic type. If we actually look at how this array interface is coded in TypeScript itself, you can see that there is an interface array. It's a generic where we use this naming of T. So T is a type parameter, and this is kind of usual naming, where you name type parameters as T, R, U, V, W. I don't know, there are some common letters that people use. So here we have an array of T. And if you look at, for example, push method on the array, we can see here that we have to push items that are of type T. And also, if we want to index the array, we have to use number as an index, and we will get back a value of type T, whatever it might be. So in our example, it was a string. Now, we can create our own generics. So we can use generics in interfaces, in classes, maybe some other things, I'm not 100% sure. Yeah, so mainly in interfaces and classes is where we use generics. So usually I would avoid naming generic parameters or type parameters. I would avoid naming them something like T or U or R, because that's not really descriptive of what's the semantics behind this typed parameter. So here I usually write T, and then I write some kind of a short description as if I was naming a variable. So to make it semantically meaningful in some way. Here we have introduced one new thing, and that is this keyword extends. So this is a constraint on this generic type parameter. So when someone uses our interface, our generic interface, whatever he passes as a generic, as T error, it has to be something that extends error. So for example, we might create 2 classes that extend error. One is like HTTP error, which has a property HTTP status. And the other one is maybe application error that has, I don't know, something that's meaningful to you, like module name, where the error happened or something. Now we can create a class HTTP error handler that implements our generic interface, where we have used HTTP error as the generic parameter. And then we have to implement handle error method, which will receive HTTP error. And similarly for our application error handler, for example, we again implement the interface, but this time we implement it with a different class as a generic type, application error. And we again implement the method that is required by the interface. And now the last and most complex example is the abstract class together with generic parameters. So here you will notice that we have created a class, but it is abstract. Now this is that you might know from other programming languages where object-oriented programming usually provides abstract classes. What this means is that we cannot create an instance of this class, error handler class. Instead, we have to create some other class that will extend the error handler class. And only then can we extend the child class. Can we instantiate the child class. Now, it is really common that you will have abstract classes in use together with generics. So we have this abstract class error handler, where we have two generic parameters, two type parameters. One is t error that extends error class, and the other one is t log response, and this one doesn't have any sort of constraints, so this can be anything. Now the abstract class can have some properties and methods implemented, but it can also leave some of the implementation to the child class. So this log method, log error method, is an abstract method, and this means that the child class will have to implement this method. So here we are only declaring the method, but the child class will have to implement it. And we are using, for example, log error method. It will receive an error object of type t error. This is our generic type parameter, and it will return a promise that should resolve to something that is of type t log response. And this basically this on error function, which is implemented here, it will just await the result of the log error method. Okay, and so what does a child class look like? So our global error handler class, it extends the error handler. The type here we are simply using error just to keep it simple, and it will return some interface which is like bug snag response or whatever it is. Now we have to implement the log error method. If we do not implement the log error method, we will again get a compile warning, because this is an abstract method from the error handler abstract class, and we have to implement it. And this will receive the error, and it will return a promise. Now, this fetch part, this is nothing to do with TypeScript. This is just like regular fetch things. Okay, and later on, we can create an instance of our child class and like wrap our code in some try-catch block where we call on error when we have to catch the error. I mean, it's a contrived example, but for example, in Angular, you have such a thing as a global error handler. So you can provide a class that is that will handle all uncaught errors in your code. Okay, next thing that is really useful is decorators. And decorating is a common object-oriented design pattern. So you might read about this pattern for Java, C# or many other languages. And you will see some UML diagrams like this. This is all quite boring. But even though decorators are something that is that exists in TypeScript, it is also a proposal to be in JavaScript standard. Although this has been in a proposal for quite a while, it is still getting updated, but I'm really not sure when we will get like native decorators. So TypeScript has decorators. They are really similar to what is being proposed to enter the JavaScript standard, but I think that there still might be some differences. So once this proposal is kind of done and we have decorators in JavaScript, they might be a bit different from what we have in TypeScript. So there are basically three types of decorators: class, method, and property decorators. They're all used to either add some metadata or to tweak the functionality and behavior of some of the things that they are decorating. So for example, in Angular, we use decorators a lot. And one example of a decorator is when you have your component. So you have a class for your component and you decorate it with add component decorator. And here you say what will the selector be for this component, what will be the template, which contains like the HTML template, what is the styles for this, so CSS for this component, and some additional things like what type of change detection will your component be using. So this is all some kind of a metadata that the decorator attaches to the class. And then this metadata can be used later on by something else. In this particular example, all of this data from the decorator will be used by the Angular compiler to compile this component. Now, a different type of decorator is a property decorator. So one really common use case where we use property decorators is when defining models for the data from the API. So for example, we can have a class user that has a property ID, and we can attach some decorators to this property. So we attach identifier and attribute decorators. And next, we have first name property. We again say that that is an attribute, but we say that, for example, API maybe returns an object that uses snake case, that uses snake case, but our property is camel case. So we can attach some metadata here that we want to actually read the first underscore name property from the raw JSON that we get from the API, but we want to map it to the first name in camel case. We can also define relationships. So if you use something like JSON API, maybe, so if user can have multiple blog posts, you can create a relationship to a blog post class. It will be an array. And we again have to rename the property from snake case to camel case. And now we could have some function like user factory, which will receive the constructor, so class user, and it will receive some raw object. And what this user factory will do, it will be able to read the metadata that is set on the properties of a class to simply remap this object into an instance of the user class, where we have like nicely renamed properties and we have relationships there. This is something that we use quite a lot, actually. And lastly, we have method decorators. Here, this is again an example from Angular. When we want to call some function, if window resize happens, then we can add this host listener decorator to the property. And when window resize event happens, it will call window resize method. This decorator is something that comes from Angular, but you can also create our custom decorators, which is this pipe decorator. And this pipe decorator will allow us to enter multiple RxJS operators here if we want to like debounce or audit time. So what this means is, so here in this particular example, we have this pipe and host listener decorators. Our pipe decorator has audit time operator. And this means that when we are resizing the window, this function will get called only once every second. during the resizing. So we don't call it too often maybe. So this is kind of an optimization. And this is what this decorator looks like, the pipe decorator, but don't worry, I won't be going over this. Now, this is kind of all the features that I think are most important when dealing with TypeScript, but let's look at how we can actually use TypeScript. So you can go to typescriptlang.org/play, or if you are feeling brave enough, you can type TS Playground in Google, but please do it in like incognito Chrome or something. So you will get this web page where you can write some TypeScript on the left, and you can see to what it will get transpiled to JavaScript. Now, of course, that's not how you develop. How you can use TypeScript is you can add a dependency, simply TypeScript, and you can add some kind of a script, let's say build, which calls TSC, that is TypeScript compile, and we are compiling index.ts file. You can see the index.ts file here. It just has a simple console log. So once we run the npm run build command, you will notice that we simply got in line next to the TypeScript file, we got index.js file, and it basically has, I mean, here it has basically the same code, but it is just in a JavaScript file, it has been compiled. Of course, that's still not how you would use TypeScript. In reality, you usually have some kind of a bundler for your JavaScript. Some of the most common ones are, let's say, Webpack and Parcel, Snowpack, or something like that. Now, I think Webpack is still kind of the most used one. So I have a quick demo to show you how you can use Webpack to have TypeScript compilation. Okay, so here is our repository. What we have here is, first let's look at package.json. So in package.json, we have a build script that simply runs the Webpack command. For this, we need to install Webpack and Webpack CLI. We need TypeScript, and we need TypeScript loader, because Webpack is kind of based on the concept of loaders. So if you look at our Webpack config, you see that our entry point is source index.ts file. And we have a loader here, which matches all TypeScript files with extension TS, and it will process them. We can also process JavaScript files if we want to. Those don't need to go through the TypeScript loader. And finally, once we are finished with the bundling process, we will get in the dist directory, we'll get bundle.js file. And okay, so let's look at our index.ts file. It's really simple. It imports two things. So first thing it imports is something from a TypeScript file. So it imports some class that has some stupid simple method. And it also imports some old JS code function. This is a function from some JavaScript file. So here I wanted to show that you are able to mix JavaScript and TypeScript code base, which is great if you decide to start using TypeScript when developing new features. But the rest of the code base, the old code base, can remain in JavaScript. And then you can slowly think about migrating the JavaScript code base to TypeScript, annotate it with types and things like that. So here, let's run the npm build command. Once it is done, we will get a dist folder here, and we will get a bundle file. Now this bundle file has like a bunch of Webpack specific things, but we can see here that we have our class. We have our class here from our class hello world TypeScript file. So it has been bundled into this JavaScript file that we can run. So we can run this file and it will log something that we have defined. Now, one more interesting thing that I would like to note is with TypeScript. If you look at the tsconfig JSON file, so this is the configuration for TypeScript compiler. You can see here that we have a lib property, and this basically defines when we are writing TypeScript code, what set of features from the language do we want. And if you put something like ES2020 or ES Next, then you will basically be using the latest JavaScript things that exist in JavaScript. So you can use like flat map or whatever was newly added to JavaScript. And another interesting thing is this target property. So to some extent, TypeScript can take your JavaScript, TypeScript can take your TypeScript files, which are using some of the newer features, and it can, for example, transpile them down to a lower version of JavaScript. So, for example, to ES5. So let's try this. So here you see that our class from TypeScript, when you look at the bundle, it got transpiled to a class. Because our target was ES6 and classes exist in ES6. However, so now I have changed in tsconfig, I have changed target to ES5. If I run the compilation again, you will notice that our class got transpiled to a simple function where we use function prototype grid, so the old way of doing object-oriented programming in JS. So here, TypeScript will do things like this for certain things. So it will not do it. It will not be polyfilling all the features, but it will do some things like this. Okay, that's it for the demo, and that basically ends my presentation. Thank you, everyone. Filip, you have been watching the chat. Have there been any questions? Maybe
no questions.
No questions. Okay, that means that I really explained everything in a nice way that everyone was able to understand. I'm glad that everyone was able to understand. Okay. So now we can take a couple of minutes break. We can come back at 7 o'clock sharp. Just so, okay, we have 3 minutes pause, just so we can shuffle around. Okay, I will let the slides spin while we wait. Okay, not to the end.
All right, let's start. So Voska gave us a nice little intro to TypeScript, and what I'll be talking about is TypeScript utility types. So what are they? They are globally available utilities, and TypeScript provides several of them. And I've basically split them into three parts based on the constructs that they're using under the hood. So we have mapped utility types, conditional utility types, and the variation of the conditional utility types, which is conditional utility types with infer. So first we'll start with mapped utility types. They were introduced in TypeScript 2.1, and they basically allow us to create new types from existing ones by mapping over property types. That doesn't mean much. So we'll go over specific examples. So first up, we have partial. Now imagine we have a to-do interface, which has the title and the description property typed as string. And we want to create a update function, which updates any kind of object that we pass it. So Voska introduced us to generics, and now we know what this type parameter t means. We can see that we have two parameters for this function. First one is object, which is type t, and the second one is mapped as partial. So we want to reuse the same object. We don't want to create a new interface, and we want to use generics because we don't want to bind ourselves to a specific interface. For example, creating a single function to update to-dos, a single function to update some other objects. And so what we do in the function is we just destructure all the properties. And now we create our to-do object and we update it. So basically partial is interesting because we'll try to desugar it now, because it makes all of our properties optional. So we can get a to-do interface, and what we get back is another type that has both title and description as optional. So this is what the definition of partial looks like in the source of TypeScript. So we have a couple of interesting constructs here. So we have the key of, we have the in keyword, and we have this question mark that Voska already has been through, and we have this p from t. Okay, now. So what we'll do now is we'll desugar in every step. We'll try to desugar as less as possible to see how TypeScript, let's say, compiles this under the hood. So within the square brackets, we're using the key of operator. Key of from a type parameter represents all property names of type t as a union of string literals. So what this basically means is we're gonna get back a union of title and description if we provide a to-do interface. So anything that can be accessed in JavaScript land, everything that's publicly available on that interface, we will get that back as a string literal. So basically, when we desugar the key of to-do, we get a union of both title and description string literals, and that's the union of string literals. So next up, we have the in keyword, and that signals that we're dealing with a mapped type. So we have the p in key of t, which denotes that the type of each property p of type t should be transformed to t of p. Basically, that means you can look at it as a loop, for example. So p will take form of both title and description, and it will replace itself on the left-hand side of the semicolon, and it will replace itself on the right side of the semicolon, which is to do from p. And then we have the question mark, which is the modifier that specifies that each property should be optional. So when we desugar this further, we can see that we have now title, which is optional, and we have description, which is optional. And on the right-hand side of the semicolons, we have the to-do, and then again, the previous type parameter p, which is replaced with the actual type values. And so t of p is a lookup type, and it represents the type of the property p of the type t, which basically means that we access the type of that property on the interface. And what we're left with is the final result. And what partial does, as I mentioned before, is it makes every property on the interface in this example as optional. Next up, we have required. As you can see, not much has changed. We have the same construct as before, but one interesting thing here is that we have the minus before the question mark, and that denotes removing the optionality from that property. So if we have the interface props here with both A and B as optional, if we apply required, we will make both A and B as required. So they will not be optional anymore. So if we try to provide to update props function just A, we will see that it will error and it will say that we need to provide the B property as well. We have read-only, same thing. Instead of the question mark, we have the read-only modifier, and it will transform every property to be read-only. And you can see that if you check the TypeScript source, you will see that freeze actually uses read-only. So let's see. Okay, next up we got pick. Now pick is pretty interesting. We can see that we have the same construct as on the map types there. We have P in K and T from P, but the only difference here is that we have a constriction on the key type parameter, and it says that it extends key of T. So that means that we can only provide properties that are available on the first type parameter. So if you have an article which has title, content, and published, the only thing that we can do when we use pick is that we can provide title or content or published. And if we want to create a type which is article preview, we're only interested in title and published. So our new type here will be a new type which will contain only the title and the published properties. And I think finally with the map types we have the record. Again, map type. This looks really familiar. P and K, return P. And now what's interesting here is that we have this constriction on the K type parameter. So key of any represents the type of any value that can be used as an index to an object. So you can use a string, a number, or a symbol to index into an object. So what we can provide as the first type parameter is a union of those three. So we can provide string literal, a union of string literals, we can provide a number there, we can provide symbols, we can provide all the permutations and combinations of them. So let's say that we have a type, which represents, which we denoted all the pages that we have. And we have this page info interface above. If you want to reuse these types, we can use record, because then we can create an object like this. So keys are all the pages that we have, and the values are actually the objects that represent the page info. Okay, so next up, we have conditional utility types. They were introduced in TypeScript 2.0, and they basically allow us to express non-uniform time mappings. That is, type transformations that differ depending on a condition. So this is a lot of mumbo jumbo, so let's get into it. First up, we'll start with exclude. Exclude constructs a type, but by excluding from type T all union members that are assigned to K. So by just looking at the verb, you basically know what's going on. So let's say we have a union of string literals, right? A, B, C. And from that, we want to exclude A and F. So we already know what the result will be, which we will try to remove A, and it will be doable because A is in the union of string literals. And it will try to remove F, which is not present, so basically we can ignore it. So the final result should be union of B and C. So this is what we want, and this is how the definition of exclude looks under the hood. And we have an interesting construct here, which reminds you of JavaScript's ternary operators. So if the type T is assignable to the type U, we select the never. Otherwise, we select the type T. So we can see now that we have some kind of control flow here, like if statements or switch statements or stuff like that, but now in TypeScript land, which gives us a lot of power. But before we get into it, we need to check what never actually is as a type. So Voska already mentioned it. It was introduced in TypeScript 2.0, and it appears only in the two following situations: either either as a return type of a function that never returns, or a variable under type guards that are never true, meaning that you could have a function that throws an error, and that function actually never completes, never returns. Even when you have void functions, they return undefined, because every function returns undefined in JavaScript. But if you throw an error, you basically, that function holds. So the type of that function is never. And for example, if we have a lot of if else's, we want to check if our variable is a string, is a number. And if we exhaust all the possibilities, the only thing that's left is never, because we'll never get in that branch of the control flow. Never has some interesting properties, because never is a subtype and assignable to every type, but no type is a subtype or assignable to never, except never itself. A lot of mumbo jumbo again, but we'll see how that will be useful in practice. And if you're into type theory, never is a type. It never is TypeScript's bottom type, meaning that it's a type of values that never occur. So before moving forward, we have a weird jump over here, right? So check this out. We have exclude over a union of string literals, and suddenly we have a union of excludes that were, so we can see that exclude was applied to each member of the first type parameter. So we need to talk about another thing before going on, and that is naked type parameters. So naked type parameters are the type parameter that's present without being wrapped in another type. So by being wrapped in another type, that means that, for example, we have a string which is actually wrapped in an array or a tuple or a function or a promise or any type that can be wrapped in another type or another generic type. But again, let's go over the examples to see how this can be useful to us. Let's say that we have two conditional types. The first one is naked usage. We have type parameter t, and we can see that if the type parameter t can be assigned to a Boolean, we return the yes string, otherwise we return the no string. Same thing for the wrapped usage, but we can see that the type parameter here is wrapped in an array or in a tuple. So if we have a naked type parameter and the type parameter is a union of types, we know from the definition now that we can distribute this generic over each member of the union. So if the relationship test in the conditional type checks a naked type parameter, which is our type parameter t, the conditional type is called the distributive conditional type, and it is distributed over a union when that union type is instantiated. So basically what that means is, if we check, we can go from this step to this step. And now we know how to work with this step because we're talking about basically atoms here, right? So number extends Boolean, no. Boolean extends Boolean, yes. And then we get a union of string literals that we got back from our conditions, from our conditional type above. But check this out, this makes sense. If you put the type parameter inside something that's wrapped, that can't be destructured further. And the only thing that you can do now is check it against the extends condition, and we get back no. So that's why we can go from this to this, because our type parameter t here is not wrapped in anything. And that means our type parameter t is a naked type parameter. And now that we can apply exclude to A, B, C, the next thing that we do is we actually desugar it with the extends above, with the exclude above that we define. So A can be assigned to the union of A and F, and we return never. And B does not extend A and F, we return B. And C does not extend A and F, and return C. And now we've talked before why never is interesting. So never is a subtype of every type. So that means that we can omit it from the union. So if you define something as never or B, you can always assign B to that. It doesn't matter if never is there or not. So think of it like adding with a 0 or multiplying by 1 in math. It doesn't matter if it's there or not. The result will always be the same. And finally, we get a union of B and C. So actually, exclude is a low-level primitive. You usually want to use it as maybe a library creator, but I needed to explain it because it's a basic construct of the next conditional type, which is omit. Omit is actually interesting because it uses both pick and exclude. And pick, we've seen that it's a map type, and exclude is a conditional type. So remember the article interface we had before. We had, if we wanted to create an article preview, we had to pick title and published. But it would be easier, especially if you're in a situation when you have 50, maybe 10 properties on an object, on an interface, and you don't need only one of them. Instead of picking 9 of them, it would be cool just to omit the one. And that's what omit basically does. If we can see the definition of omit here. We have the restriction on the k parameter as it extends key of any, and we can see that we pick and exclude. So we composed exclude inside of pick. And since we know how exclude works, right? From article we exclude content from the properties of article, from key of article, which returns the union of title and published, the union of title, content, and published. We exclude content, we're left with title and published, and then from article we pick title and published. Oh, sorry. Yeah, and basically that's it. The last one left on the conditional train, we have the non-nullable. We can see that if our type parameter t extends something that's assignable to null or undefined, we do never, otherwise we return the same value. So what non-nullable will do, it will get distributed over strings, an array of strings, null and undefined, and null and undefined will return never, and that's how we selectively move them away. So non-nullable email addresses will actually be of type string or array of strings. Last, we got conditional utility types with infer. Introduced in 2.8 the same way as conditional types. So within the extends clause of conditional type, so we have the type parameter extend something. After that extends, we can use the infer keyword to infer a type variable. So let's see that in action. We have the return type, which is the most useful from them all, I'd say. If we declare here a function and the return value, the return type of that function is an object of two variables A and B. We can see that if we want to extract this return value, we will use return type here. So you can see that we constrict our type parameter t here as something that is function-like, right? So we have the args, which are typed any, meaning any number of arguments, and we return any here. So this is a, let's say, this is how we would declare a function in TypeScript. And then we check if type parameter actually extends, if it actually extends something that is function-like, and then we use the infer here. That means that in the type parameter R, we will save what the best function returns as a type. And then we return that R, otherwise we do N. And then when we do return type of F, what we get back is actually what we expected. And if we try to pass it something that is not function-like, we will get an error. Parameters, same thing, but you can see now that instead of infer being in the return section, it is in the args section. And then we can get a tuple of all the parameters that function gets. So we can see in the on line 12 there that we have a tuple of two members. The first one is an object of A and B, and the second one is a callback function, and they both match the function declaration from on the first line. And we can work also with classes. Instead of doing something that is function-like, we extend T to match something that is class-like with a new keyword, and by placing infer either in the arguments in the constructor or in the return value, we can infer the instance of that class or the constructor type of that class type. And that's it. So now let's use all of this knowledge that we got to create something custom that is still not in TypeScript and could be potentially useful. So imagine this situation. We have an interface user, right? It has two properties, name and email. Name is string, and email is either a string or it can be null. So we want to create a custom type that flushes out, that returns only the properties on our interfaces, on our types that have that are not nullable. So by applying non-nullable property keys, which we will create on the user, we will get a string literal name. If we had another property there, for example, ID, which is a number, we will get here a union of string literals ID and name. And we want to make it composable, right? So maybe we just want to create non-nullable property keys type, which will pick only the non-nullable property keys. So we want to use it like you've seen omit uses pick and exclude. So let's start. This is what the declaration looks like. So all the constructs here are familiar. We have the mapped type here, we have the key of, we have the in keyword, we have the conditional here, and we have the property access here. So let's go step by step. Let's destructure this, let's desugar this, and let's see how all of this works. So on our first step, we will replace the type parameter t with the actual interface, the user, which was defined in the slide before. We will then desugar the key of on the user inside the mapped inside the square brackets on the left side of the semicolon, and then we know that the in keyword means that you can think of it as a for loop. P becomes name, P becomes email, and then it's assigned on the right hand side as well. So we get two properties, name and email. And then we replace them as well on the right-hand side of the semicolon from the step above in the conditional. So we get something like null extends user of name. If that's true, we return never, otherwise we return name. And the same thing for email. What we will do in the next step, we will desugar the lookup properties. So user of name and user of email from user and the name from user. So we have here null extends string and null extends string and or null. Same step here. And now we will resolve the conditionals. So we can see that null does not extend string. So we return that property, which is name. And we can see that null extends string or null. So we return never. So now an interesting thing. We desugar the key of user, which will give us all the properties on that interface. And then we can apply the thing that we learned before. So we can apply each of these each of the string literals in the lookup property individually and create a distributed union of distributed. And basically that's it, right? So step before. So if we access name from this object, this line on the line 17, we will get the string literal name. On line 18, if we access email, we'll get never. And we've seen that we can just omit never from the union, and we get our final result, which is just the name, string literal. And that's it basically. So we've been through what utility types are. I've shown some mapped utility types with the sugared partial. We've seen some other examples. We've seen conditional utility types, the sugared exclude and omit, and seen some other examples. We've seen return type, which is a conditional utility type with infer, and some other examples. And we put it all together under the non-nullable property keys type, and let's say solidified our knowledge. And that's it. Any questions?
No, there haven't been any questions.
Nice. Then I made it all clear as well.
Yes, you have explained it perfectly as well. Okay, excellent. Well, with that, we are basically finished for today. I will let the slides look a bit more. So yeah, as a reminder, we are always employing. So if you are great at TypeScript,
you are.
or you like Angular or React, please drop us a line and apply for the job. We are always looking for people. Oh, sorry, I forgot to enter the frame. Yeah, so please, if you have any questions or comments, you can leave them in the meetup event if you want. And if you're interested in applying for a job, visit infinum.com/Voska. I'm not sure if /jobs works, but you can basically visit the homepage and you will be able to find it. And that's all, folks. Thank you, everyone. It's been a great talk. I was excited to talk about this, and now we are done with this part of our lives. Okay. Thank you, everyone. That's it. Bye.